Assalamualaikum and a very good day to everyone. My name is Nur Patricia Aisyah binti Faisal. I'm going to present you assignment 2, which is signal analysis of periodic and aperiodic signals. So let's go to the task 1A, which is continuous time Fourier series CTFS. In this task, I have got two questions regarding to the continuous time Fourier series, which I need to find the input of continuous time and impulse response signal xt and ht with the time period t equal to 6. So this is the mathematical function that have been given for xt and ht, while the next are to find the CTFS signal up to 5 harmonics. And lastly, for task 1A is verifying the answer using MATLAB. So let's continue to the task 1A1. So the mathematical function given is xt equal to -2, which is from 0 until 2, while 0 for otherwise. As we can see, the graph going to -2 from 0 to 2, while otherwise is 0. So next is task 1A, 2, which the mathematical function for ht I have divided into 3 steps, which is the first step is xt plus 1. So it shows that the signal is going to -2 from -1 to 1, while 0 for otherwise. Step 2 is xt over 2 plus 1. The signals show that -2, t that from -2 to 2, while otherwise is 0. The last step is -x t over 2 plus 1 show that the signal going upward, which to 6 from -2 to 2, while otherwise is 0. So settle for task 1A2, we move to task 1A3, which I need to evaluate the continuous time Fourier series CTFS up to 5 harmonics. So given the t equal to 6 while k equal to 5, from the equation we can produce the mathematical function for ht, which t from -2 to 2 is 6, while 0 for otherwise. So we must use this formula, which is ck equals to 1 over t, integrate from -infinity to infinity, ht, exponential of -jk omega naught t. So we just substitute the value and it will get ck equals to 1 over 6, integrate from -2 to 2, 6 exponent of -jk omega naught dt. The last equation will be 1 over jk omega naught times exponent jk2 omega naught minus exponent -jk2 omega naught. And by using Euler formula, we can get 1 over jk omega naught 2j sine 2k omega naught. And we can simplify the equation and results as 2 over k omega naught sine 2k omega naught. Since omega naught equals to 2 pi over 6, then we can just substitute the omega naught into the equation and we get 6 over k pi sine k 2 pi over 3. So the k is equals to the time periodic, which is k is 0, 1, 2, 3, 4 and 5. After we substitute into different k, you will get the different answer which are k equal to 0, we get C0 equal to 0. While K1, we get C1 equals to 1.654 and angle 0 radian. While K equal to 2, we get C2 equals to negative 0.827 and angle 3.14 radian. K3 will get 0 for C. K4 will get 0.413 angle 0 radian. While K5 we get negative 0.331 angle 3.14 radian. So this is the magnitude spectrum that have been plotted based on the calculation. And this is an angle in radiation spectrum. For the next task is proving all the calculation using MATLAB. So for the T0 is equal to 6, while omega naught equal to 2 times pi over T0. The limit that have been set is from negative 1.5 times T0 to 1.5 times T0. N is the input that we need to set for the number of harmonics. A0 is the DC value. We use for N statement to get the signal. So this is the continuous time signal with the number of harmonics is 5. And this is the magnitude spectrum, which the value are similarly to the calculation that have been made. And this is the phase spectrum in radian. Alright, so we're going to the task 1b, which for continuous time Fourier series, CTFT. So the task need to compute and plot the frequency spectrum of the Fourier transform or omega from negative 5 to 5. So the equation given is xt equals to 0.6 exponent negative 0.5t sine 3 pi t ut. So first, I have changed the equation for sine 3 pi t using Euler formula. So it will get exponent j3 pi t minus exponent negative j3 pi t over 2. After we multiply the two components, it will get as shown. Taking the Fourier series transform, whereas exponent negative at ut, we will get 1 over a plus j omega. In this situation, our a is equal to 0.5, so we can just substitute it into that formula. Same as exponent j3 pi txt, we'll get xj omega negative 3 pi. After we have replaced the equation into Fourier transform, we will get like this. And don't forget to change j square into negative 1. As the question asks, we need to find the xj omega for omega from negative 5 to 5. So here are the results of the calculation that have been made, and this is the frequency spectrum based on the calculation. So the MATLAB for task 1b, I'm using Sims function for the variable t and omega. So just directly put the function and Heaviside is for ut function. And we can get this frequency spectrum as the values same with the calculation. I just use negative 100 to 100 to get the overall for one signal. And this is for the magnitude spectrum. And lastly, the phase spectrum. So I think that's all from me. Thank you for watching.